Hillbilly Blue Balls, also known as Billy Blue Balls, made this video last week. And undoubtedly, this was a response to the discussion that you and I had about perspective and how it relates to Polaris and angular size change and how we can apply it to flat Earth and observations. So what Hilly Blue Balls chose to do in this video was to use these blocks. They look like Jenga blocks, and they're all arranged equally spaced away from each other, and they're all the same size. And basically, what he's trying to show us here is that perspective is a real thing, but as far as the globe Earth arguments are concerned, they don't use perspective to represent obstruction, because they prefer using orthographic view. Because in orthographic view, you're able to show everything pretty much from a side view. You're able to represent like all the objects that are being observed or all the objects that are in question. And in perspective view, you don't really get the opportunity to do that. So the argument that he was making here is that the only time where we see perspective, which is things getting smaller the further away they are from us, in relationship to our observation or viewing point, the only time perspective is a factor is when the objects are different distances away from each other. But as you can see here in this example, we don't see perspective from a side-on view because these objects are equally distanced away from us. They're all at the same distance away from us. That's why we don't see that effect. That we only see perspective when we're observing objects that are moving further away from us. But if they're equally distanced away from us, we don't see this effect. As the fence posts move away from us, their sizes change. And these measurements can either be angular size or apparent size, just depending on how you choose to measure these. But the fact still remains that objects that are moving away from us are changing in size. They're reducing in size. They're not actually reducing in size, but their apparent size is reducing. The fence posts remain the same size as long as we view them from equal distances. It's only when we view them from different distances that we start to see this perspective effect. The higher up you go will affect the rate of size change. So what I was trying to do was trying to get like a fixed rate to sort of calibrate how these objects are changing in size the further away they move from us. But one thing I realized is that there's no fixed rate as far as perspective is concerned. All that we can say for sure is that things that are moving away from us are always going to be reducing in size. The angle that you're viewing these images from is what's going to determine the rate. There are different calibrations of measurement that we can use to measure these. Since we're looking at photographs, we can either measure pixels, inches, centimeters, millimeters, points, picas, or columns. But it doesn't really matter what scale you choose to measure these objects. The fact still remains that the further away objects move from us, they change in size. Doesn't matter what unit of measurement is being used, that fact still remains. So in reality, we know that anything that's below our eye level can't obstruct things that are above our eye level. And I'm using this red line in this image to represent our eye level. The ground appears to rise up and get closer to our eye level as a result of perspective. Our eyesight tends to make things converge to a point. The further away in the distance, whatever it is we're looking at is. So this is something that isn't taken into consideration in orthographic view. When we're looking at things in side view, we can't really represent this apparent rising of the ground and this apparent stooping of the ceiling. These two things can't be represented in orthographic view. On the sides here, we can see that there is this shrinking or this apparent angular size change that happens the further away we look in the distance. This is also something that isn't represented in orthographic view. 3/4 of this object is below our eye level, and 1/4 of it is above our eye level. Now, what I'm going to demonstrate to you is if we have an object that is the exact same size as what we're looking at in the distance, if it's closer to us, it's going to be larger in angular size than what is further away from us. And the result of this is that something that's shrunken or reduced in apparent or angular size as it moves further away from us can be obstructed by something that is closer to us and is larger, as long as it is all below our eye level. So you can see that this object here is being obstructed by another object that is the exact same size. The factors to keep in mind here are that the size, the difference in angular size is what is resulting in this obstruction. They show us an image in a side-on view and ask us, why is this being obstructed? We should be able to see it. And they neglect representing angular size change. They also neglect representing the effects that we discussed prior to this, which is the ground appears to rise up or get closer to your eye level the further away you're observing objects in the distance. Now, this is not represented at all in this image, and it gives the misguided idea that this is what you would expect to see on a flat Earth. But realistically, this is not how our eyes work. This is not what we see in reality. We have a hydrostatic leveling rig, and this is a tool that you can use to measure the horizon in relationship to your eye level. And we can see that at sea level, the horizon is actually at our eye level. Anything that is below our eye level can't obstruct anything that is above our eye level. So we notice that in most of these observations, all of the obstruction is taking place below our eye level. If we have waves that are closer to us in the foreground, if they're larger in angular size, is there a possibility that they could obstruct something that is further away, something that's reduced in size? And we notice the horizon drop by saying that we observe horizon drop, therefore we're on a curved surface. And they completely ignore atmospheric effects. Not until recently, when they admitted that the horizon is apparent, it's always subject to refraction. So keep this in mind whenever they want to mention that the horizon is dropping as a result of curvature, when in actuality the horizon doesn't have a fixed location. It's either closer to us or further away from us based on atmospheric effects, not as a result of Earth's geometry. Why this is happening? I believe it is a result of atmospheric refraction and not Earth curves. Globers state that looming is what causes us to see further than what we would normally see on a geometric globe model. People are asserting that effect that we're viewing is actually looming, when in actuality it's not. It's inferior mirage.
An inferior mirage of the sky below the boat.
It is the sky that is being inferior miraged, creating the illusion that the boat is floating, when in actuality it isn't. It's just the sky that is being refracted. What would be required for the looming effect would be a colder layer of air below a warm layer of air. So therefore, the light would bend towards the denser medium, which is the cold air, and it would bend in a downwards direction, which would cause what we're looking at to be loomed upwards.
What's just been described is how they describe the boat being raised up and the effect that would be needed for their argument for that to happen. So this is a devil's advocate from the globe side, what they say about looming and what would be necessitated for that to happen.
But in actuality, that's not what's really happening. The sky is just being inferior miraged below the boat, creating this effect. And I think this is what the globers think looming is, but it really isn't. Because do you really think this is a hologram of the actual boat being loomed up behind Earth curve?
The globe heads would assert that this is the true horizon, the geometric Earth curve edge shown in their model marked with an X and labelled horizon. If you use off-centre vision, you can see that the horizon is precisely where it would be on any other day, and so is the boat. In other words, if you came back when you didn't have an inferior mirage of the sky below the horizon, so that's where your mirage comes from, this is an actual description of what's actually occurring as opposed to the demonstration that was on 2 slides ago. The point is that what we actually have is a horizon behind the boat slightly because it's quite close to the photographer. The sky is then mirage below the boat, giving you a false horizon, which is this line here. The true horizon, if you want to call it that, would be slightly behind the boat. And if you use off-centre vision, you don't even have to adjust the contrast. You can see exactly where that line is.
Light tends to bend towards the denser medium. So if we have a colder layer of air above a warmer layer of air, for example, if there's a warm layer of air on the surface of this water and just above it is a colder layer of air, that light that is traveling is gonna bend towards the denser medium or the colder air, causing what we're looking at to sink downwards. So this could be sinking refraction as well. So there are several things that could lead to this other than just Earth curvature. But as far as the globers are concerned, it is only Earth curvature that can result in this type of effect.
In terms of how we would actually view this, we'd get the view through this box. But as with Muppet Vision, we're seeing the actual box representative of the viewfinder in the camera. So we're seeing the side of our own head represented by this box. You wouldn't see this, you'd only see what's presented in this picture. Now, what would be presented in this picture if this mountain was a mountain and right next to you would be a gystonking enormous mountain in the foreground. These mountains here would be massive because they're right next to you. However, these mountains here are considerably further away and would be teeny tiny. But as you can see in my representation, each and every one presents itself as exactly the same size as the one next to it. So it's a very useful way of removing perspective. But when you've got a picture that's showing you something close to you in the foreground being exactly the same size as something far away, you know that there's no perspective, otherwise known as apparent sizes, being accounted for. We can attribute a particular value to each of these mountains. We can give them a whole number value, which would be feet and inches or meters. So I can say that this is a 1,000-foot mountain, this is a 1,000-foot mountain, this is a 1,000-foot mountain, this is a 1,000-foot. So in the mathematics for Earth geometry, all of the targets remain the same exact size. And when you get your picture of a guy on the left, target on the right, well, you can write any value you like on this line. I can call this distance 10 meters, or I can call it 1,000,000 kilometers. I can increase the number on this till it fills the entire line, and it won't change the representation of the picture. It doesn't make this any smaller, because if I write 6 foot on this and 30 foot on this, i.e. 6 foot on the man on the left and 30 foot on the boat, and I put 10 million in between in terms of the distance between them, it won't change the representation. But the fact that the boat's completely vanished when you have an actual picture, number one, you don't see the side of your own head. You can't see yourself in the picture. And number two, everything that's further away is going to get smaller. This tree here is obviously much, much bigger in the picture than the trees in the far distance because of perspective. But if you stick it side on, it's very useful for removing that aspect. And you can say that the boat, in the case of this image, that's, I don't know, let's call it a reasonable distance, 20 miles away, has slightly vanished due to angular limitations. And what I mean by angular limitations is where they draw a single line, or in the case of the Earth curve maths, they draw a tangent to their Earth curve edge obstruction physical geometric horizon. But what you've actually got is an angle. You've got an angle to the top of the boat and an angle to the bottom of the boat. Now that angle, if the boat was right in front of you, would be a much wider angle. And the further away you go, the smaller the angle becomes. That would be the apparent size of the boat, not factored in when you put it in Muppet Vision side on. Well, that's how they've removed perspective from the Earth curve maths. They've removed apparent sizes. How do you know? Well, because they'll be giving you the sizes in feet and inches or meters, and those values do not change with distance. Unlike reality, things in reality that are further away are much smaller than things that are much, much closer to you. This tree here isn't necessarily much, much, much bigger than this tree in the distance. It's just a lot closer. Its apparent size is larger. Now, ironically, they're all babbling on at the moment because of the black swan about how the geometric horizon, necessitated in the globe model, is actually, quote unquote, apparent. Now, number one, all horizons are apparent. It's part of the definition. The apparent position where the sky meets the ground, or the position where the sky appears to meet the ground. The sky doesn't meet the ground. All horizons are apparent. But they introduce this extra horizon with the word apparent because we can't see their physical necessitated geometric horizon that's in their model, marked with an X and labelled horizon. When we can't see it, suddenly it becomes apparent. Totally redundant term. Now, the reason this is interesting for this conversation when we're detailing perspective is apparent would be the mathematics that you would require to include perspective. Apparent sizes. And they don't use them. They're not using angular size, otherwise known as apparent size, representing this boat with two lines to the top and to the bottom from your perspective. You've just got a fixed value, whatever I gave it earlier, I can't remember, 30 foot boat and 6 foot man. And those values will never change. Therefore, it's easy to hijack the effects of things getting smaller into the distance till they disappear, and things will disappear from bottom up with a limited enough angle. I'll give you an analogy in a moment. And they can call that effect of things getting smaller till they disappear Earth curve.
Billy Blueballs just commented that I wonder why those fence posts are all the same size. So he clearly still doesn't get it. They're further away from us. Their apparent size is reducing. Now, this is the reason, they expect us to be able to see Australia from New York, because in Muppet Vision, everything is the same size. Everything is on the same level, and there's no atmosphere. Everything is geometrically represented as what you'd expect it to be with no atmosphere. So they clearly don't understand how this effect works. Regardless of how many times we try and explain it to them, they're just not going to get it.
Indeed. So if I give my analogy for bottom-up obstruction, because that's normally the last nail in the coffin, people say, well, things are disappearing from the bottom up, therefore they must be being physically obstructed by an Earth curve edge currently being denied and called apparent, with this redundant term included in the description of a horizon. Nevertheless, bottom-up obstruction, if I take a brick and place it right in front of me, it's very easy to see it has a very large angle. The apparent size of the brick is quite large if it's close. Now, if I push that brick, singular, out to the distance of 1 mile, there's a good chance that that brick becomes too small to see. The angle to the brick. Again, with my boat in front of me, the boat has a very wide, large angle. Whereas, in this case, if we're talking about a brick, you put the same exact thing on the horizon, the brick, once it reaches the horizon, becomes very, very small. So, in the same way as some of the leaves on this tree can't be resolved, a brick on the horizon, if this is a mile, just for analogy, would be too small to see. So a single brick at 1 mile disappears. Now, if I now pile on top of that brick another 20 million bricks in the form of a skyscraper, the angular resolution of the brick at the bottom is still too small to see. But the bricks that have been piled on it have got a wider angle. You've increased the angular resolution of the stuff on top of it. It doesn't alter the fact that at the bottom of that building, the brick that disappeared at a mile has still disappeared. The angle's still too small. It doesn't increase the angle of the bottom brick by building on top of it. Ergo, the brick at the bottom has still disappeared at a distance of a mile from bottom up due to an angular limitation. Now, if it was a boat, the boat, analogous to the brick, at a given distance will have the bottom section disappearing through angular limitation, and it will continue to disappear due to angular limitation from the bottom up. Sod all to do with Earth curve, everything to do with perspective.
It's a viewing angle. Like we're not able to see that angle that's below where those bricks are, because what they could say is that if things are reducing in angular size, then they should all reduce uniformly. And they don't understand that the reason that we can't see the bottom of buildings is because of an angular limitation. It isn't just an angular size change.
Muppet vision, as they like to present it. If I draw my angle to the top and to the bottom of this boat, well, the bottom section of the boat has a very small angle. And as it gets further and further away, that angle will get smaller and smaller. So if the boat was right in the foreground, the angle to the bottom section of the boat is still quite wide to the bottom section. And as the bottom section gets further away, the angle to it is more limited. It's not just one angle for the entirety of the boat. It's made up of infinite angles within whatever resolution that you can see. But the bottom, most acute angle is going to be the one that disappears the first, because it's the most limited. And why is it the most limited? Well, because we've got this line. The ground you're looking over limits your angle of view. Now, above you, you've got an infinite angle. You can see all the way up. But down here, you've got something that's going to limit the angle that you can see things at. And the further away, the more limited the bottom is going to get in terms of angular resolution, therefore disappear first. And that's precisely what we observe because of perspective. Their assertion in Muppet Vision that we had earlier with the guy on the left and the boat on the right, we've got a straight line between target and observer for the ground and a straight line for the view, what he's seeing, dotted line from his eyes on the left to the boat on the right. Well, in this image, as you can see, and as demonstrated very well by Babs, this is raising up. These two are exactly the same amount of liquid. That's the point of the apparatus. And yet it's raising up. And that's going to continue to happen. If this extended out to the horizon, you'd see all of these raising up, raising up, raising up, raising up, raising up. So not curving down away from you, like in their Muppet Vision representation, or in their bastardization of a flat Earth world, just a straight line still in Muppet Vision, where you can see forever. What's happening is it's rising up, while they tell you it's curving down. Well, what does that tell you? Well, it's not Earth curve, it's perspective. That's why it's rising up, not falling down.
Exactly. Everything that's on the ground starts to move closer and closer to your eye level the further away it goes, which is not represented in Muppet Vision.
And yet they tell you on the globe that from your position where you stand, everything's falling away from you, down. You're at the top of the sphere for everybody, and from your position looking out towards the horizon, you could draw a tangent line between you and that horizon and work out what's going to be obscured, because everything's falling away from you. You're always looking down at things falling away, curving down. Drop. There is no drop.
Yeah.
Raising up. With perspective.
Isn't it funny? Isn't it funny how horizon drop is only visible with elevation? And what they fail to realize is that if you're looking at the horizon drop, you're looking at it at an angle, at a downward angle, as opposed to a straight line. So you're looking at a further distance. If you consider this to be a triangle, the base of the triangle would be shorter than the sloped side. So with elevation, you're looking through a further distance, which has more atmosphere, therefore leading to more refraction. So if we're looking through more refraction, the horizon is going to be refracted more than it would be at ground level.
But their assertion when they describe horizon drop, the dip angle, is the assertion that we have a geometric horizon, a physical Earth curve. Now, as you raise in altitude, in case this isn't obvious, you should eventually get to the point where the Earth curves into a round ball that they show you with NASA pictures, quote-unquote pictures. But that's the effect. You go up higher, you see more curve, right? So they assert that that is the effect that you'll measure when you get up high and measure the horizon dip. Well, that assertion comes with the necessity for a physical, geometric Earth curve edge as a horizon. Something that's been relinquished and debunked by the black swan. So you can't assert that this is a physical
Right.
Earth curve obstruction that you're going to measure a tangent line to, especially as they're claiming, A, we've got no straight lines to draw, it's all refracted, and B, it's non-physical, according to them. So none of the geometry works in these assertions where they claim that the horizon's dropping. We all know full well the horizon's not a physical actual place, it moves with the bloody weather. So drawing tangent lines to it and asserting that it's a physical edge to their sphere for boats to go over is beyond absurd. Now, to round this off, we as flat earthers, anybody who's watching that's new, get asked quite frequently why our boats aren't going over the edge of a disc flying up through a sky vacuum in the form of a flat earth society reification model that's literally got an edge and boats and the sea falling off it. The reason this is engineered into the flat earth society narrative is because their weakest part of their argument, heliocentrists on the globe, their very weakest part is their edge. Now, they don't call it an edge. They call it Earth curve. It's going over Earth curve. That's what they say. But it's an edge to their sphere with geometry and physicality that they're all currently relinquishing because it's debunked by the black swan. We don't have a physical geometric horizon. And that's why they've got to ask us for our edge. Attack is the best form of defence. Rather than focusing on their edge and the boats going over it, when they say boats go over the curve of the Earth, they ask us about our edge that we don't have and don't reify. It's been foisted upon us. But it's because it's the weakest part of their argument. Sorry, go ahead, Babs.
Yeah. And things can only go over an edge. It has to be an edge in order for it to cause obstruction. And as far as the high altitude pictures that show Earth's curvature, those are cherry picked. They just cherry pick Dwayne Kellum's footage and take snapshots of when the barrel distortion makes it look convex. They don't show you when it looks concave or when it's all wonky. They only show you the cherry picked images that they want you to see that support their fantasy.
Okay, now, like you said, you can draw a line. There's actually straight lines going from the person's head to the top of the boat and one going to the bottom of the boat, correct? And that angle is very wide when it's close and very narrow when it's further away, correct? So Nathan said that with this boat, this side view, this orthographic view of the boat, right, when it's really close to the observer there, the angular size would be very large, and the further away it gets very small. Correct?
No,
yes, that is correct.
No, that's not correct. No.
But that's what you said.
No, it's not included in your Earth curve calculator. This is a representation that's distorting reality. We don't see the side of our own head. It's representative of your Earth curve maths. So when we're looking at pictures like these, we're talking about Earth curve maths, Muppet vision, not reality. That's not what happens in reality at all. But in your maths, there is no such description of the boat being close with a big angle and boat being far away with a wide angle. It's always represented in feet or meters.
But that's what you said. You said when it's close, the angle of the lines connecting, the
say it
top
a second
of the boat,
time.
the bottom
I'll
of the
say it a
boat,
second
and the
time.
person-
I'll say it a second time. It is not included in your maths. My example was to highlight the missing angular relationships in your maths. So when you say, well, when it's close, it's got a wide angle, what in your maths? No, it hasn't. That was my point. Are you going to whistle past that completely for something spurious that's not relevant to my description of your maths that does not include apparent sizes? That's what I was detailing. Do you want to address that? Because that's what I was focused on.
Well, that's what angular size means.
It's not in your calculator, though, is it? Angular size, Brenda. It's always going to be feet.
Yeah, it is calculated.
No,
Yes,
it's always in feet and meters. It's not angular sizes. You just don't understand how you calculate
What
words.
other size? It could be in inches. It could be
No,
in millimeters and meters. It
inches
doesn't
isn't angles. Inches doesn't change with distance. Don't tell me it's got angular size and then say it could be in inches. No, it'd need to be in an angular size.
You don't know what angular size
Why are you
is,
laughing?
do you?
Excuse me.
You're a fucking
excuse
idiot.
me. Don't tell me with an ad hom what I don't understand. That's an ad hom on an attack. So I've got to remove you because you're going to tell me what I do and don't understand. Your maths doesn't include angular sizes, Brenda. For the globe?
Yes, it does.
No, it doesn't. You just said it could use inches.
Yes, it does.
You're just parroting, yes, it does. No, you've just said it could use inches. Inches isn't angles.
The size is, the angular size is, the angle, you can determine.
Why are you telling me what you can determine? It's not in your maths. You use feet and inches like I've said. Now you're babbling on about what you can determine. I don't care. All you've got in your maths is feet and inches for a target that will not change with distance.
And Nathan.
Why are you stuttering and saying my name?
Angle theta.
You don't have angles in the Earth curve maths.
To determine the length of the opposite side of the triangle, Nathan.
What's that got to do with the angular size of an object that you're...
That's how you can calculate it.
It's not in the Earth curve maths, though.
Yes, it is. Because
no, it's
if you
not.
know
You're
one
a liar.
side of the triangle and then the angle theta, then you can calculate the other side of the triangle. You mong.
Why are you insulting me and calling me a mong? You do not have angular sizes in the Earth curve mathematics. All targets will be measured in feet and inches or meters and stay those values regardless of their distance. Their angular size will not change. You drawing a sagittar is Earth curve geometry based on Muppet vision with no apparent sizes included.
The apparent size is the size that it appears, and it depends on its distance from you.
And that's not included in the Earth curve maths for about the fifth time.
Yeah, it is.
No, it isn't. Why do you keep spewing this baseless assertion? I've qualified how it isn't there. This boat in the Earth curve maths is always going to be 30 feet. And you're going to tell me how many feet are blocked based on a sagittar you will draw to a physical Earth curve horizon obstruction edge that will block it based on how many feet are missing. Feet which will not change with distance. You'll tell me how many feet and inches are missing from a 30-foot boat. And that's not accounting for angles in any way, shape, or form. You doing geometry and drawing angles from your geometry is not accounting for angular size. You are incorrect or a liar. The Earth curve calculator does not include apparent sizes.
Nathan, is there anything...
Shut up, don't ask me a question, you're an idiot. Yeah, they've hijacked perspective, basically. They've taken the effects of things getting smaller and smaller into the distance, kept the values for those items the same at any distance, and called the effect Earth curve, using angles of geometry and drawing sagittars, not accounting for things getting smaller into the distance. People who come here and say that it does account for angular size are just liars.
Blue marble science. In the orthographic view, the observer and the object are the same distance away. Therefore, no change in the parent size due to perspective. Quote me accurately, or I may do another video.
Read him again.
Okay. In the orthographic view, the observer and the object are the same distance away. Therefore, no change in the parent size due to perspective. Quote me accurately, or I may do another video.
In orthographic view, they're not necessarily accounting for perspective at all. That's the first issue. That's the point of using it. You're normally drawing a single line between target and observer. This is the line that Brenda took. Let's discuss your understanding and knowledge of orthographic representations, rather than addressing the point. The point being that, why is he now asking us about the angular representation in an orthographic view when his mathematics using orthographic view doesn't use angles? So, blue marble science, you complete numpty. Why would you be asking us about the angular representations that aren't included in your orthographic maths? Is our acumen about random orthographic maths that do include angular sizes relevant when your maths doesn't? Now, given that you're asking us about how angular sizes are represented in orthographic view, I'd like you to show me those angular sizes in your mathematics. Now, bearing in mind I've just made it quite clear that they're not there, I'll just win this out straight away and say, you complete loser, You, like Brenda, have missed the point and tried to highlight a straw man to burn in terms of our acumen and understanding about orthographic representations that do include angular sizes when yours don't include angular sizes, the point of our argument. So, we'll discuss the angular sizes and how they're represented in orthographic view as soon as you show them in the maths for an earth curve that hijacks perspective and doesn't account for angular size change. So we'll discuss them when you show us them in your earth curve maths, blue marble retard. They're not there, moron. That's the point of our argument, not our acumen in terms of how well we understand orthographic views, not necessarily applicable to your earth curve maths that doesn't have angular sizes in them, you complete dick. Hope that addresses your question. Quote me precisely, or I'll make a video about it. No, I don't give a shit. You're a moron.
I don't understand what he's trying. The observer and the object are the same distance away.
I understand what he's doing. What he's doing is saying the man on the left and the boat aren't moving. They're the same distance. They're a fixed distance. So there will be no angular size change. Well, yeah, that's because this cartoon's not moving. The boat's not actually sailing away from him in the image. So no, this is never going to represent an angular size change. But it would and could, if I just simply draw a line that represents an angle to the top and bottom of it, represent an angular size. But his maths doesn't include angular sizes. So he's justifying it by saying, well, when we've got a fixed picture, there's no angular size change. So there's no delta of the thing we're asking to be included in the maths when the maths has hijacked the very effect of angular sizes. Oh no, let's detail angular sizes and how they change. And in this picture, they don't. So his point is, in this picture, there's no representation of an angular size change. Well, no, that's because there's not a second boat in the picture and two lots of angles being drawn to it. So no, based on your language, no, you don't need to argue very much about an angular size change in this picture with a static boat. However, your mathematics for a globe doesn't include angular sizes. That would be the point we're making. Maybe make a video about how your maths doesn't include angular sizes and the boat's always going to be 30 foot. Even if I draw 1,000,000 miles on this line, our point being, this boat will always be 30 foot in your maths. It'll never change in size, even though it's getting so small at 1,000,000 miles that there's no sodding way you'll see it. But your maths will still see it. You just draw it halfway around an earth curve. I don't know, 3,000 miles away, but it's still 30 feet. Yeah, well, it hasn't reduced in size. Angular size, apparent size. For your apparent maths that you don't have. Fools! Blue Marble's completely retarded. He thinks his clever use of wording's going to catch us out. No, I don't think so, Blue Marble.
He's just conceding. He's just conceding our point essentially by saying that side-on views can't show perspective. That's our point, and he's conceding it. And the people that watch him are too stupid to realize that. So we have to educate them on that.
That's exactly right, Babs. That's my point. The way he forms this question is exactly what Babs says. He's conceding that. Now, has he ever stood at a dock and waved goodbye to people leaving on a cruise ship? Does that cruise ship not get smaller as it gets away from you in distance? Is he going to say it's the same size as it was in front of him in the dock where he couldn't see anything because it was blocking things that were behind it? Is this guy insane?
Yeah, I mean, according to him, on a flat Earth, everything is the same size with distance. Nothing changes. You should be able to see Australia from New York.
Yeah, they're crazy. Him and Brenda both are crazy, man.
Yeah, they're so brainwashed by their own mathematics that excludes perspective that they expect us to see forever on a flat plane because their maths implies that you can see forever if you straighten out the line that's obscuring it. Now, what that actually tells you is they've hijacked the effect of perspective and called it Earth curve. So if you straighten out the line in their representation, this would be a quarter of a sphere with the boat down here somewhere and the man up here somewhere and a sagittar and a tangent and all sorts of geometry and angles being drawn, but no angular sizes. The boat on the other side of the curved Earth would be 30 feet and the man rising up and down and giving you an apparent horizon, geometric though it is in their model, would be 6 feet. And that's all the maths ever shows. So even though in their geometric maths on the Metabunk site, for instance, it's literally got a quarter of a sphere in the pictorial representation, that quarter of a sphere, what would that be representing? Several thousand miles. Well, you can't see a boat that's 30 feet at several thousand miles, but in their maths and their depictions, you can. So when you straighten out that curved line that's got several thousand miles represented, and you drawing a straight line between target and observer, and just saying that the reason you can't see it is because of a bloody Earth curve getting in the way, that's no longer geometric and capable of obstruction unless you suck all the atmosphere out. But that aside, when you straighten out the line, they think that you should still see the boat, because there isn't an Earth curve in the way. It's like, well, no, the Earth curve was never in the way, but the boat was definitely too small to see halfway round or quarter of the way round your sphere. If it was a sphere, you'd still have the effects of perspective, but they're completely ignored in your maths. In reality, hijacked by their maths and called Earth curve. Things get too small to see as they get further away, it's perspective. Well, in their maths, that doesn't even happen. Things are falling away from you even though they're rising. If you stand with a boat right next to you on the harbour, you could very easily be looking down at the bottom of the boat. Well, by the time it gets out to the horizon, it's no longer looking down at a very low angle to the bottom of the boat in the water beneath your feet. It's rised up as it's gone away from you with perspective. Isn't that amazing? Just like those depictions of the water. Well, the bottom of it is rising up like the boat would do if it went away from you. Yeah, you'd look at the bottom of it. You'd have to look right down at your feet to see the bottom of the boat when it's in the harbour. But as it goes out towards the altitude, goes out towards the horizon, is it going to be curving away, down, falling, dropping, with the perspective view that they remove and hijack with Muppet vision? No. The bottom of the boat's going to rise up and up and up and up and up and up and up until it reaches the horizon, and then at the point of the horizon's where it's too small, and it'll start disappearing with angular resolution limits based on the deck that you're looking over and the limited angle to the bottom of it. None of which is represented in this view. All you've got in this view is an eternal view forever and a value that you can attribute for the distance between it, and never will it get too small to see. Precisely why they've used it for the Earth curve maths. When Andrew Thomas Young does his detailed explanations for how refraction works, he disclaims at the very end that they're all done on a plane. None of them are done on a curved surface. And then he just gives you the mathematics for assuming R if you want to do it on a curved surface with the maths at terrestrial refraction rates. So he does a little magic trick where he baits you in with refraction effects all detailed on a flat surface, and then says, oh yeah, these apply to a curved Earth. We just changed the maths. Go to this other website and it'll tell you all about it. Fight the Flat Earth saying, basically, something that gets completely debunked by that statement. He's saying that I think you wouldn't have any of these refractive effects on a flat plane. They're all mandated by spherical surfaces.
Refraction doesn't work on a flat plane because you need a change in the temperature of the light. And do you know how you get that? It's because of the curve and the light going through those different temperatures.
I left a comment underneath saying, hang on a second, all of their actual references from their global worshipped Andrew Thomas Young, they're all done on plane surfaces. Literally none of them are done on curved surfaces. His argument being, oh, these are all necessitated by a curved surface, but yet none of the examples given by Andrew Thomas Young are using curved surfaces at all. Just a disclaimer for how it is all actually curved, even though they're all done on plane surfaces. So all the examples, not one back his argument that they're all done on curved surfaces. Then none of them are. What a complete idiot. You think he'd actually look before spouting that nonsense?
Is Fight the Flat Earth on Brenda level or on Sean Hawkins level?
Don't know him. Don't have any interaction with him. Don't care. But I do see occasional things getting trimmed out from him that are quite useful. Him asserting we have physical geometric Earth curve obstructions.
Obviously, when we say the horizon, we're talking about the physical obstruction of where the Earth starts to curve away from us, okay?
I've trimmed that out because Helen Degenerates trimmed it out, and I was like, yeah, that's useful because they're all denying it at the moment.
We do.
Oh, so now we do. Only 30 seconds ago, ladies and gentlemen, he made it plain we don't have a geometric horizon, and now we do.
No, we don't have a geometric horizon.
And this is another example where someone's trimmed out him saying, all of these atmospheric effects must be happening on a curved surface. It's the only way they can. Or words to that effect. I'm not doing a terrible job of paraphrasing, but either way, you're like, wow. Literally your examples on the website that you're referencing at the moment are all disclaimed to have taken place on a flat surface. Oh my God.
Yeah,
well, that was
ridiculous.
that was going to be my comment, that obviously when he did his calculations on the refraction page on his website, he said they were done on plane surface, right? And then But if you want to reify it to globe, go to these other websites. Well, wouldn't that mean that he did those calculations with no atmosphere?
No.
Yeah, because on their own rhetoric is the only way you can get the geometric measurement proper is if you had Earth without an atmosphere.
No, they won't have done that. I know they have a sky vacuum that's defying the second law of thermodynamics, but there's never going to be a circumstance permitting them to do that now, is there? So no.
I know I'm being funny about it, meaning they're saying that the only way is if Earth didn't have an atmosphere. But when he says he got his calculations, he did it on a plane surface. Well, with atmosphere or without? Make up your mind.
There's only one level, too. It's the Brenda level. There's different shades of it. Fight the Flat Earth is definitely below that. Hillbilly Blue Balls, the redneck retard, is like echelons below Brenda. Mrs. Frigging Inches is angular size. And then call somebody an idiot.